In this example, we're given the input-output differential equation for a second-order system and a set of initial conditions. The value of the output, y at t equals 0, and the derivative of y with respect to time at t equals 0. We want to determine a state space model for this system and use MATLAB to calculate the response to a set of initial conditions. First thing I need to do is choose my states. For a differential equation of this type, I'll always take the highest order derivative in the equation, d squared y by dt squared, integrate that, and choose that as one of my states. So x1 is going to be the derivative of y with respect to time. States are always the outputs of integrators, so I can integrate this and choose x2 as being that, which is just y of t. Now, if this is x1, x1 dot is equal to d squared y by dt squared. If I solve this original equation for d squared y by dt squared, I get 100u minus 2 dy dt, which is just x1, minus 100 times y, which is just x2. Now the equation for x2 dot is just the derivative of y, which is just equal to x1. So if I write my state equations, x1 dot, x2 dot in matrix form, that's my A matrix times x1 and x2 plus a B vector times u. My first equation, x1 dot, is 100 times u minus 2 times x1 minus 100 times x2. x2 dot is just 1 times x1, nothing times x2, and nothing times u. So this is A, and this is B. Now my output equation is an equation of the form y is equal to c times my vector of my states plus d times u. So y is equal to some two-element row vector times x1, x2, plus some number times u. From my state definitions, x2 is just equal to the output. So there's nothing times x1 in that equation, 1 times x2, and nothing times u. So this is C and this is D. I now have my state variable model. Now let's take a look at the initial conditions. Y of 0 is equal to 10. Y is just equal to x2, so 10 is equal to x2 of 0. The initial condition on my second state is 10. dy dt at t equals 0, which is just x1 at 0, is 3. So there's A, B, C, and D, and my initial conditions. Now I can go to MATLAB and simulate the system response. I'll just do this problem at the command prompt. My A matrix is -2, comma, -100. Semicolon takes me to the next row, which is 1 and 0. B is a column vector, 100, and 0 is the second element. C is a row vector. First element's 0, second element is 1, and D is 0. For a natural response, I also need initial conditions, which I'll put in a vector named x0. So x0 is going to be a column vector. The initial condition of the first state is 3, and the second state's initial condition is 10. I'll create a structure that's a model of the system, so sys is equal to ss of a, b, c, d. And finally, the initial command will calculate the natural response and plot it. So the initial of sys, comma, x0 is my initial condition. There's the response. It starts out at 10, which is my initial value of y. It goes to 0. Any natural response should eventually die out, and it oscillates. If I check a damping ratio, the damping ratio is less than 1, so it's underdamped, and this all seems very reasonable.